Let us discuss chemical formula. This is an example of a molecule. As we have learned, atoms combine to form molecule. And if the atoms of different element combines, that molecule is called as compound. In this example, as it is shown that there are two sodium atom, one sulfur atom, 4 oxygen atom. So these combine to form a molecule. So one question arises here, why in this molecule two sodium atoms are combining? Why only one sulfur atom? Why there is 4 oxygen atom in this molecule? So we need to discuss the molecule, how these atoms are combined, that we need to discuss, and this representation of a molecule is called as chemical formula. That means we need to discuss how the chemical formula can be written for a molecule. Let us define what is a chemical formula. Definition for chemical formula. Chemical formula of a compound is a symbolic representation of its composition. It means that a chemical formula is nothing but the symbolic representation of whichever atoms are present and how much number of atoms are present in a molecule. Why it is called as symbolic representation? Because here in this molecule there is sodium atom, sulfur atom, oxygen atom. So instead of writing the name, we are writing the symbols like sodium, sulfur, oxygen. And we are also representing how many number of sodium atom is present, that is 2 number of sodium, 1 number of sulfur, 4 number of oxygen. So we are representing the symbols of the element which is present in the molecule and its composition. Its composition means how much it is present. So what is the composition of these elements in that molecule, that is represented in a symbolic form, that is called as chemical formula. So the chemical formula of different compounds can be written very easily. So in this session we will be going to discuss how we can write the chemical formula easily for a molecule. In order to understand the concept, let us take an example. It is a very interesting example which is given in your textbook. That is an example of a man and an octopus. Do you know that how many number of arms are there to an octopus? That is 8. And for human, that is 2. So let us find out what is the combining capacity of an octopus and an human. As octopus has 8 number of arms, that is why it is called as octopus. Let us count the number of arms. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 arms for an octopus, and for a human there is only 2 arms. Now these arms we can consider as a combining capacity. These arms can be considered as a combining capacity. Now what is this combining capacity? Let us discuss about it. So if we consider an octopus like this, as we have discussed, there are 8 arms for an octopus, and if an octopus hold a man in such a way that the 2 arms of man is locked like this, that means a single man can hold the 2 arms of octopus by his 2 arms. Now count it how many arms are remaining. 1, 2, 3, 4, 5, 6. Now 6 arms are remaining. So can you tell me how many number of man can hold the other arms of an octopus? Let us count in this way. Already one man holds its 2 arms. One more man holds its 2 arms. Now how many possibilities are there? That is the third man, fourth man. So that means an octopus, its 8 arms and the 2 arms of 4 man is completely locked. That means the 8 arms of octopus and the 2 arms of 4 man is completely locked. So if we want to make a formula for this combination, we can call this is a combination of an octopus and 4 man in such a way that the 2 arms of all the 4 man, that is all the 4 man, its 2 arms and the 8 arms of octopus is completely locked. So now this combination, that is the combination of a octopus and the octopus and the 4 man, this combination, let us represent a formula for this combination. So in order to representing a formula, we need to give a representation to an octopus and to a man. Let O is represented for an octopus. A symbol O is represented for an octopus and H is represented for the each man. In that case, let us make the formula for this combination. How we make the formula? So here there are an octopus and there are 4 man. So how we write this combination? There is 4 number of man. 1, 2, 3, 4. 4 man and 1 single octopus. So this combination we can represent it by a formula, that is H4O1. Why it is 4 here? Because there are 4 number of man and only there is single octopus. Therefore we represent O1 for an octopus and H4 for the human. That is why the combination make this formula H4O1. Similarly, when we talk about atoms, atoms also have combining capacity, that is called as valency. So here the valency or the combining capacity gives a formula. Similarly, the atoms also have the combining capacity, or we can say just like an arm. Here the hydrogen have a single arm, oxygen have 2 arms. So that are the combining capacity of hydrogen and oxygen, or we can say the valency of hydrogen is 1, that is the combining capacity of hydrogen is 1 and the combining capacity of oxygen is 2. Why hydrogen have a single arm, that is a single valency? Why the oxygen have 2 valency? That description will be, explanation will be done in detail in next chapter. So let consider there is a single arm for hydrogen and 2 arms for oxygen. So let us find out what will be the formula in this combination. So just count how many number of valency are there for hydrogen. So in the figure there is single valency, that means single arm. For the case of oxygen, valency is 2. Now let us make the formula. How we make the formula? The valency of H is 1. the valency of oxygen is 2. Now let us make the formula. For this making a formula, you have to use crisscross method. What is crisscross? Just make a cross like this. Now when you make the cross of this, what you will get a formula for this combination, that is here H. Now 2 for hydrogen, so we'll be writing a subscription 2 for hydrogen. O, you can see 1 numbers goes for O because we are crossing out here. So 1. And it is not necessary to write subscription 1 here. That means we need not to write this 1. So just rub it out this. So what is the chemical formula here? It is H2O. What is H2O? It's a water molecule. So we have generated a chemical formula for a water molecule. So how we have generated the formula for water molecule? By writing its valency first. What is valency? The combining capacity. First we are writing the combining capacity for the hydrogen, that is 1. For oxygen, that is 2. And when you are doing the crisscross, this is called as crisscross. When you do the crisscross, so at the time you will be coming with a formula of water, that is H2O. What it shows, just like octopus, one octopus can hold 4 humans. Here 1 oxygen can hold 2 hydrogen. So you can see the arm, there are 2 arms for hydrogen, 2 arms for oxygen and single arm for hydrogen. So you can see the arm of oxygen and the arms of hydrogen is completely locked. So this rise to the formula for a molecule. So I hope it is clear to you what is the combining capacity and what is the chemical formula. So the combining capacity of a different element will give rise to a chemical formula. So let us define what is a valency. Combining capacity of an element is known its valency. So just now we have seen in the case of water, 1 is the valency of hydrogen, 2 is the valency of oxygen. So that valency is giving rise to the symbolic representation of a molecule, that is called as formula. So how easily you can make a chemical formula? For this, first you need to learn the valency. Once you have learned the valency of a different element or different ion, it is easily you can make the chemical formula. And one thing also is needed, that is the symbols of elements. So these 2 things if you learned, you can easily frame the chemical formula, that is symbols of elements and the valency of elements. If you have by hearted, it will be very easily you can learn the chemical formula, or we can say you can easily make the chemical formula for a molecule. Here are some valency for some important element which is given here. Hydrogen have a single valency. Helium, because it does not forms compound, therefore it does not have valency, 0. Lithium 1, beryllium 2, boron 3, carbon 4, nitrogen 3, oxygen 2, fluorine 1. Neon, again it is a noble gas, it does not form any compound, so it is 0. Like the sodium 1, magnesium 2, aluminium 3, silicon 4, phosphorus 3. So when you go through all these valency, you can find out that valency comes in between 1 to 4. So you need to learn this valency first. and that can be learned with the help of this chart which is given in your textbook. That is a table number 3.6. That is the name and symbols of ions. Ions have charges, that is either positive or negative charges. In the case of sodium ion, there is one positive charge. So one positive charge means the valency of sodium is 1. Potassium 1 positive, that means the valency is 1. Silver 1 positive, valency is 1. Copper can have 2 valencies here. That is, in this case you can find out the copper have 1 positive charge, but in this case the copper have 2 positive charge. So copper can have 2 possibilities here, at this 1 or 2. Similarly, you can find magnesium 2 positive, therefore 2 valency, calcium 2 positive, therefore 2 valency, like this. So the valency you can easily learn when you have learned the ions. Ions with its charge, if you have learned, you can easily learn its valency. Let us take an example of polyatomic ion, that is ammonium ion. What is the formula for ammonium ion? NH4 plus. It's a polyatomic ion because it have number of atoms and there is a single positive charge. This positive charge is actually the overall charge of this. That means it is not the charge of nitrogen, it is not the charge of hydrogen. It is the overall charge. So that is a polyatomic ion. So this charge, that is a one positive charge, is the valency for the ammonium ion. So here the combining capacity for the ammonium ion is 1. Similarly, the other polyatomic ions like hydroxide ion, there is single negative charge. So the valency you can take as 1. Nitrate, that is -1, 1 can be taken. So these are the polyatomic ions and their charges represent its valency or the combining capacity. So let us start the writing of chemical formula. For this, some rules are there. So we have to follow that rule, and from this we can easily make the chemical formula. Let us take some examples. First example, sodium chloride. What is sodium chloride? It's a common salt. Sodium chloride is a common salt. First of all, in order to make a formula, first you need to write the symbols as sodium chloride. That means it is made up of 2 atoms, that is sodium and chlorine. So what are the symbols for sodium? Sodium is represented by Na and chlorine is represented by Cl. Chlorine is represented by Cl. Now, what is the combining capacity of sodium and Cl? That we need to find it out first. So, better you refer the table. In this you can find out the sodium have a single positive charge, and where is chlorine? The chlorine have a single negative charge. So, what is the valency of sodium ion? That is 1. 1 is the valency for sodium, and for chlorine 1. So since the chlorine can be named as chloride in the case of ions, so just write down the valency. That is the valency of sodium is 1. For chlorine it is 1. How we got this value? With the help of the table which is given in the textbook. Now you have to do crisscross. What is crisscross? That is crossing like this. Cross it. So when you cross it, now you make the formula, that is Na1Cl1, because the 1 numbers goes for Na, 1 numbers goes for Cl. That means Na1Cl1. As I told you, the number 1 is no need to represent the number 1. So better you rub this number 1. Rub it out. So what you got here? That is NaCl. So what is the formula for NaCl? That is, it is a sodium chloride. So formula for sodium chloride is, that is NaCl. That is a chemical formula of sodium chloride. So while writing a symbol and also a name, first of all you have to follow a rule. What is that rule? First, the metal should be written first, the symbol of metal should be written first, then the symbol of non-metal is written. In the name also, the name of metal, that is sodium is a metal, is written first, then the non-metal is written. So this is a rule which you have to follow while writing the chemical formula and the name. So that is a rule that is given in your textbook. That is the rule number 2. What the rule number 2 say? When a compound consists of a metal and a non-metal, then the name or the symbol of the metal is written first. That means the metal name and its symbol should be written first. Then only you have to write the name and symbol for the non-metal. In this example, we can find out just sodium chloride we have explained just now. Calcium chloride. Calcium is a metal and oxygen is a non-metal. So first we will write the symbol for the metal, that is calcium, then symbol for the non-metal, that is oxygen. So this is a rule which you need to follow for writing a chemical formula. Let us see what is the first rule says. The valencies or the charges on the ion must be balanced. What this rule say? Because while making the formula, whatever the valencies are there, or we can say the charges of the ions, it should be balanced. Because when you make the crisscross, these valency get balanced. So that is the rule first says. Let us take another example. Hydrogen sulfide. Hydrogen sulfide. That means the two elements which are here, that is hydrogen and sulfur. Hydrogen and sulfur. Symbol for hydrogen is H and symbol for sulfur is S. Now what is the valency for these? Let us go through that table. In this you can find out the valency of H, that is 1 positive, and the valency of sulfur, that is in the form of sulfide ion, that is S2 negative. Hydrogen sulfide, that is H plus S2 minus. So valency of sulfide is how much? 2. Valency of hydrogen is 1. So let us take that value in that problem. So we are writing the valency for hydrogen 1, the valency for sulfur is 2. Now you do the crisscross like this. When you do the cross, write the symbol. Now you can see that 2 numbers, that is the 2 number goes for hydrogen. So we write the subscription 2 here for the hydrogen, and for the sulfur single. This 1 goes to sulfur. So you have to write a single number, that is 1 for sulfur. As I told you, it is no need to represent the number 1. So better we can rub it out this one. So now no need of 1. So we can write the formula, that is H2S. H2S is the chemical formula for hydrogen sulfide. Here also we have followed the rule, that is the valencies are balanced, and we have hydrogen sulfide. Hydrogen positively charged, sulfide negatively charged. It is written in this way. So that is a hydrogen sulfide. Next example, carbon tetrachloride. Carbon tetrachloride, that is a symbol R carbon. For C is the carbon. For chlorine it is Cl. Let us find out what is the valency of carbon and chlorine, that is 4 and 1 are the valency. So what is the valency of carbon and chlorine? That also you can be represented in this table also. Here you can see the valency of carbon is 4 and the valency of chlorine, that is 1. So on the basis of this table, we can make the formula for carbon tetrachloride. So the valency is 4 for carbon, 1 for Cl. Now do the crisscross. When you do crisscross, so C, one number goes for carbon, so C1, and for Cl, 4. As I told you, one number, no need to represent, so rub it out. So what you got the formula now? You got the formula, that is CCl4. So the formula is CCl4 for the carbon tetrachloride. Next example, magnesium chloride. Magnesium chloride, write the symbol Mg for magnesium, Cl for chlorine. The valency, or we can say the charge. Charge is 2 plus for magnesium and 1 negative for Cl. So cross it. When you cross it, we will get the formula MgCl2, because Mg, one negative charge, that is 1 goes to Mg, so we are writing 1 here, and the 2 number goes to chlorine, so we are writing 2 here. As I told you, number 1 is no need to represent, so we'll rub it out this one. So what you get the formula? You will get the formula that is MgCl2. So what is the formula now? We can say the formula is MgCl2. So that is all about this example. So the valency can be taken in the form of charges, like here it is taken, and these charges get completely balanced. Why it is get completely balanced? Because the overall charge, when you find it out for magnesium chloride, there is no net charge here, because magnesium overall charge, there is no net charge. Why? Because as the rule first says, it completely get balanced. That means magnesium, that is the 2 positive charge of magnesium, and for 1 chloride ion, the charge is 1 negative. So there are 2 chloride ion, so we can say there is 2 negative. So 2 positive, 2 negative get cancelled. So what we can say, the overall charge is 0. So that is called as balancing of the charge, as the first rule say. So in the chemical formula, the charges or the valency should be get balanced. So in order, when it get balanced, then only the overall charge of the molecule, it become 0. We can say the net charge become 0. Let us take next example. Formula for aluminium oxide. Aluminium oxide, that is a combination of aluminium and oxygen. Valency for aluminium +3. You can refer the table and you can find it out. Its valency is +3, and for oxygen it is -2. Now do the crisscross. When you do the crisscross, you will get 2 number for aluminium, so I'm writing 2 here, and 3 number for oxygen, so I'm writing 3 here. So we got the formula Al2O3. Let us check the valency, whether it is balanced or not. So what is the charge for 1 aluminium ion? The charge of 1 aluminium ion is +3. But how many number of aluminium ions are there? 2. So that means +3 and +3. Now what is the charge on oxygen? For 1 oxygen, the charge is -2. So there are 3 number of oxygen. So I'm writing -2, -2, -2. That means this +3 +3, that is equal to +6. -2, -2, -2, that is -6. So +6, -6 get cancelled. So we can say that the overall charge is equal to 0. That means the charges are completely balanced here. That means the charges, that is charge on the aluminium and the charge on the oxygen get completely balanced. So there is no net charge on the compound, that is aluminium oxide. So I'm not writing any charge on this. That means it shows that there is no net charge on the aluminium oxide. Next example, that is calcium oxide. Calcium oxide, symbol Ca, oxygen O, the charge +2 for calcium, -2 for oxygen. Do the crisscross. When you do the crisscross, you will get a formula Ca. 2 numbers goes for calcium, so Ca2, and for oxygen 2 numbers goes for oxygen, so I'm writing 2, subscription 2 here. In this case, you can see both have number 2 here, 2 and 2. Better you take the simple ratio, that is 2:2. When you make into the simpler form, we know that both are 2. So when you divide this 2, so you'll get 2 divided by 2, that is 1, is to 2 divided by 2, that is 1. So what you got the ratio 1:1. So that means in some cases you can simplify it into further. So that simplified form represents its chemical formula. So instead of writing Ca2O2, what we can write? That is CaO. That is Ca1O1. So this one no need to write. So we can, instead of that, we can write CaO. From this, we come up with another rule which is given here. That is, if the two valencies are same, that means if the two elements have same valency, as in the case of this one, the calcium oxide, because here the two valencies are same, in that case, when it comes the formula like Ca2O2, we have to simplify it and the formula is written as CaO. Because 2:2 ratio, when you simplify it, you will get 1:1. So instead of taking 2, 2, we will be taking 1, 1. So that's why the formula comes CaO. So that is a rule which need to follow here. Next, sodium nitrate. Sodium nitrate, the symbol for sodium is Na, nitrate NO3, nitrate ion. Just go through the table of polyatomic ion. Nitrate ion, that is NO3 minus, 1 negative charge. So the symbol NO3 minus, so 1 is the valency. So the charge is -1. So +1 -1. Cross it, you will get the formula NaNO3. Next, calcium hydroxide. Symbol for calcium Ca, hydroxide OH minus. OH minus is the ion, hydroxide ion. So the negative charge, 1 negative charge represents its valency 1. So +2 -1. When you cross it, you will get the formula, but in a different way. Just look at here how I am doing. When you cross it, 1 goes to calcium. So I am writing Ca1. Now number 2 goes for hydroxide, that is OH. What is OH? Hydroxide ion. But this 2 number is for both oxygen and hydrogen in the hydroxide ion. So if I am writing the 2 here, what it means, that is for only hydrogen. If I am writing this 2 here, that is only for oxygen. So instead of that, what we can do here, in such a case, we will be using the bracket sign. We will be using the bracket sign. So we'll write Ca1OH. This 2 is for both oxygen and hydrogen in hydroxide ion. So we'll be using a bracket and we'll keep that number 2 here. So that means in that case we have to enclose that ion in a bracket, and that subscription, that number should be written in this way. So 2. So what will be the formula for this chemical compound? That is CaOH whole twice. How we say this one? CaOH whole twice. CaOH whole twice. CaOH whole twice. So this is actually a rule which is given. That is the rule. If the compound formed with a polyatomic ion, the number of ion present in the compound is indicated by enclosing the formula of ion in a bracket. That means just now we have discussed in the case of calcium hydroxide, the polyatomic like ion like hydroxide ion, it is enclosed in a bracket sign, and that number is represented by writing that number of ion outside the bracket. That number is written outside the bracket. So this is the point which is actually, this rule is given for indicating this type of representation. That is a representation called chemical formula. So in such a case that having a polyatomic ion will be using the bracket sign, and that polyatomic ion is represented within the bracket and by writing the number of ion outside the bracket. So let us do the next example. Sodium carbonate. Sodium carbonate, sodium Na, carbonate CO3. Now +1 for sodium, -2 for carbonate. So when you cross it, you will get the formula Na2CO3. In this case, no need of bracket. Why? Because the one number goes to carbonate. One number goes to carbonate means if you are writing in this way, Na2CO3 whole bracket 1. It is no needed because anyhow we'll be not representing the ones number here. So there is no need of bracket in this case. So no need of bracket. So simply you can write the formula Na2CO3 because number 1. If number 1 is there, as we are not representing the number 1, so no need of bracket. Next, ammonium sulfate. Ammonium sulfate, ammonium ion have one positive charge, sulfate ion have two negative charge. When you do the crisscross, what you will be getting the formula here, because NH4, that is ammonium ion have, when you do the crisscross, 2 goes to NH4. So that is NH4. So we need to put the bracket because 2 sign goes for NH4, 2 number goes for NH4. So we have to write 2 here. Then for SO4, 1. 1 number I told you no need of bracket. So directly we write SO4. So the formula becomes NH4 twice SO4. So this is the formula for ammonium sulfate. So in this video we discussed about how to frame chemical formula. So for that first you need to learn the symbols of element and the symbols of ions, its charges, and the polyatomic ions and its charges. And by following the rules, we can easily frame the chemical formula. So this is all about this video. Have a nice day.